Hello, I'm Jared Skeens. Welcome to the Zoom room. Today, I would like to cover Hermas 1 Quadratics, Part 3B, and I'm excited about this. I'm calling it the Magic Potion. The reason why I'm excited about it is because it's a new mathematical development, just came out in 2019. It's not even in the curriculum yet. A guy by the name of Po-Shen Loh recently developed this new method as an alternative to the quadratic formula. We discussed the quadratic formula in part 3B, and if you remember, it was a little complicated in how to figure it out. This one is much easier to figure out, and it can do all the things that the quadratic formula does. Now, to help me remember the guy's name, I call it the Magic Potion. Technically, it doesn't have a name to the method yet. They just say the alternative to the quadratic formula. But I like to call it the Magic Potion in honor of the guy who developed it. So let's get to it and see how this thing works. Well, just like we did in part 1 when we looked at factorization, we looked at the two roots and we worked backwards to compare it to our normal quadratic ax squared plus bx plus c format. So when we start with the roots and work backwards, we see that we have our roots. We get up to here where we have the factors, and then we get up here to where we have the equation. Remember the three levels that you need to be able to work with: the solutions or roots, the factors, and the equation. And when we work it backwards, we see that we have this relationship between the roots, that P plus Q, the two roots added together, is related to the B, and the two roots multiplied together is equal to the C. That's going to be very important. This is something we did in part 1. Now, if you notice, I put the A in red. You can leave the A there if you want, but if you do, you have all these fractions in your formula. So just like we did in part 1 with factoring, we saw that there was a way that if you wanted to, instead of dealing with the factors of C and the factors of A, you could multiply the A to the back so that you didn't have to deal with the factors in the front. When we got to part 2, with the completing the square, we also didn't want the A, and we factored out to the front and then worked with the quadratic. When we got to part 3A, the quadratic formula, we saw that one of the first steps we did was we divided the A through. So everything that we've done so far, there's been a way of getting rid of that A. And actually, that's what I would recommend. Different teachers might approach this differently, but I prefer to get rid of that A at the very beginning. If there's a non-1 number as your coefficient, divide it through and look at what your new B and your new C values are. So I'm going to get rid of that A for us. So when I get rid of that A, it's going to disappear from here, disappear from here, disappear from here, disappear from here. Now, to me, this looks like a little bit simpler formula, not quite as scary. So if we just follow our previous, procedure, this is what we end up with. Like I said, another teacher might prefer to leave the A in the formula. To me, this looks less intimidating. Plus, getting rid of the A is something that you're already used to. So if we go with that step first, dividing the A through if you have one, and if we start looking at our graph, now we get some visual help here, something we didn't have with the quadratic formula. We look at our graph, we can see that a typical parabola has a vertex that's on an axis of symmetry. In other words, this graph folds in half and has identical parts on both sides. So as you move away from the vertex, each point along this parabola, as you move away from the vertex, is equal distant away from your axis of symmetry. So these two roots are the same distance away. We're going to come back to that. Now, that means that this axis of symmetry is right in the middle. So I put a little M there. This is the midpoint of our two roots, and it's on the axis of symmetry, and it happens to identify for us the x-coordinate of our vertex. We actually saw this in the quadratic formula. The x-coordinate ended up being negative b over 2a. Well, it's still negative b over 2a, but remember I decided to divide the a through first so that we don't have to deal with the a anymore. So this is the new b value that you have, the opposite of b divided by 2. It's still our x-coordinate, and it happens to be the midpoint. Well, let's think here. How do we find midpoint? Well, if you remember back in IGCSE material, you learned that the midpoint is found by basically you average it. And how do you average? You add the two values and divide by 2. So if we want to find the midpoint, we add the p plus the q, then we divide it in half, and that will be our midpoint. Okay, well, let's look at how this relates to up here. Notice that here is a p plus q, and here is a p plus q. And this p plus q is related to the b. So in other words, our b is equal to a negative p plus q. That's this section right here. Okay, so that's our b value. So if we just want p plus q, all we have to do is get rid of that negative sign. So negative b, or the opposite of b, is our p plus q. So if we want to find the midpoint, all we have to do is divide p plus q divided by 2. So if we divide p plus q by 2, this is how we end up with our midpoint, which is the x-coordinate of our vertex. So it's just the opposite of b divided by 2 is our starting point. It's the middle. Now, from the middle, we want to go in both directions. In other words, this distance here and this distance here are the same. Now, we're not going to call it x because we already have a lot of x's. We don't want to confuse ourselves. So I'm going to call it z. So from the midpoint, we go an unknown distance to this root, and we go the same unknown distance to this root, and we can find the root. So if we start with our midpoint, which is just the opposite of b, divided by 2, and to go this way, you add this unknown value, and if we go the other direction, that means we subtract z because we're going in the negative direction on our x-axis. So if we subtract z, that will be this root. So this entire factor here is actually our q, the negative b over 2 plus z. This entire factor here is actually the p. And a very interesting thing here is this is multiply. And we see up here that p times q is equal to c. So if this represents p and this represents q and they're multiplying, then this equals c, which is the value right there in our quadratic formula. So if you can visualize the picture, which is nice, visualization. Midpoint is something you already know. All you're doing is adding and subtracting the symmetry to the midpoint. That creates the roots, and the product of the roots is c. So it's a much easier mentally understandable concept than going through algebraically the entire complete the square process with no visual aid to it. It's a little more complicated in the quadratic formula. Okay, so that helps explain it. Let me set up for an equation and I'll show you how the practice of it works in actually solving a quadratic equation. Okay, for our first example, I've actually chosen a quadratic that, yes, it does factor. Factoring would be the more efficient way, but I've chosen an easy one just to show you how this new method works. So we want to apply our magic potion to this quadratic. Again, our goal is to solve for the two values of x. So using our new method, notice, first of all, there's no a, or a is an understood one. Our lead coefficient is 1, so we don't have to worry about that. Now, what we want to remember is we're starting at the midpoint. The midpoint is the opposite of b. So our b is a -6, so the opposite is 6 divided by 2, and that is our midpoint. And so we're going to add to the midpoint our symmetry, which we don't know what the symmetry is, the length of the symmetry. And we're also going to take our midpoint and we're going to subtract the symmetry, that is, go in the other direction. And these now represent our roots. So the midpoint plus a certain value will get us to the first root. Our midpoint minus the same value will get us to the second root. The product of our roots is the value c, which is 5. So quite easy to remember and to fill in. Now you might end up with fractions and you can end up with radicals. This even works with complex numbers when you get that far. It works everything that quadratic formula does. So now when we get this, 6 divided by 2 is 3, okay? So we have 3 plus z times 3 minus z equals 5. Now, notice this makes a difference of squares, makes it very easy to expand it, because in a difference of squares, the nose and the mouth actually cancel out. You get a plus 3z and a minus 3z. So you don't even have to worry about the nose and mouth part of your smiley face method. All you need to do is the 2 eyebrows. So 3 times 3 is 9. Z times -z is a -z squared equals 5. So if you add the z squared to the other side, I'll show my work here so that then if you subtract the 5, you know, this is easy math here. You could do this in one step if you're, you know, good at moving this over here and this one over here. And so we get z squared, because this is gone, equals 4. And when you square root both sides, so notice the math is pretty easy. This cancels and you get z equals, don't forget, plus or minus 2. It's the plus or minus from the root. Now this is not your final answer. This is the symmetry. So don't forget that the z is not x. We're looking for x. Z is the symmetry. So the symmetry goes back to our midpoint. Our midpoint was 3. So what we want to do is take 3 plus or minus 2. The 3 plus 2, 3 minus 2. So what we get is 3 plus 2 equals 5. And we also get 3 minus 2, which equals 1. And if you come back up here and look at this from a factoring point of view, the factors of 5, 1 and 5 that add up to 6, well, they're 1 or 5. And they would have to be in your factors. They would be negative x minus 1, x minus 5. And when you solve those, you get x equals 1, x equals 5, which are the 2 answers that we got from our magic potion. Okay, so I really like this new method. It's a lot easier to understand visually because you have that idea of your midpoint plus or minus the symmetry, and your product of your 2 factors is equal to the c term, which you already know from factoring. that you take your factors from that C term. So it really is complementary to everything you've learned so far. It's not quite as complicated like having to go through the complete the square procedure. So let me set up one more example to help you really grasp what's going on here. Okay, I've set up another example here. This time I used one that includes an A to it. Okay, so this one will be you know, a little bit more of what you would expect. It doesn't factor. Obviously, the factors of 3 and 2 cannot subtract to give you 8. So this doesn't follow factoring. So this means you would have to use the quadratic formula, or in this case, we want to try our new magic potion. Okay, so like I said before, we don't want the A's in our formula. That A kind of complicates things. So we're going to divide that through. When we divide the 2 through, we get x squared plus 4x. Yes, we do end up with a fraction. Don't freak out about the fraction. And then when the 2 divides into the 0, you still get 0. So here's our new A, B, C. These are the A, B, C's that we're working with. We got rid of that lead coefficient because we don't want to deal with that in the formula. Okay, so that was easy enough to do. Now we want to follow our formula, and remember your parabola is symmetrical about the vertex. So the vertex is the average of the roots. It's the opposite of B divided by 2. The opposite of B divided by 2. So the opposite of 4 is a negative 4 over 2 plus or minus our symmetry will get you to the roots, and the product of the roots is equal to our C term, which is a negative 3/2. Again, don't worry about the fraction. Your calculator can help you with that anyway. So here is a negative 2 plus Z, negative 2 minus Z. Once you understand what's going on, you can do that in your head and not have to write it out. I just want to make sure I'm showing you the steps here, even if you want to go back and show that this was divided by 2 so that you understand what's going on. Now you multiply it out. Again, you don't have to worry about the nose and mouth. They cancel out. This is a difference of squares. Negative 2 times negative 2 is 4. Minus Z squared equals our negative 3/2. Add this Z squared over and also add the 3/2 over. So Z squared, adding it to that side, will equal 4 minus 3/2. Okay? Now, you can use your calculator, but this is quite easy. 4 is the same thing as 8/2. So 8/2 minus 3/2 is 5/2. And if you notice, when we square root both sides, we're going to end up with a radical. Okay? Now, if the question is asking for exact answer, then you want to rationalize your denominator, meaning you want to multiply top and bottom by root 2 and change this to a root 10 over 2. Okay, that would be the more appropriate form for a radical. Now, if you're looking for decimal answers, don't worry about it. This isn't your final form anyway. So remember, the Z is your symmetry. Our midpoint is the negative 2. So we have negative 2 plus or minus root 10 over 2. Again, if you want the exact value, you would put it in this form. If you want the decimal form, then you would just do this on your calculator, and you would do this on your calculator. Okay? So if you use your calculator, you get negative 2 plus root 10, or you could even put the root 5 over 2, but make sure you keep it in the radical. So root 10 over 2, and we get a negative 0.4 419 to 3 significant figures. And if we do this one, just scrolling back through and changing that plus for a minus, we get a negative 3.58. Notice 3 significant figures doesn't mean a certain number of decimal points. So careful to follow the instructions. Sometimes it says a certain number of decimal points. If it doesn't say anything, it's automatically 3 significant figures. So these two then would be our answers. You'd get the same thing with the quadratic formula. If you want, you can try it out and see for yourself. So here we have our new magic potion. I really like it because it's more, I think it's easier to understand because it involves things you've already worked with. Completing the square means you're introducing an outside number that's not visible, okay? Even the symmetry we can see in the graph. Even though we don't know what the symmetry is, we can solve for it and then plug it in and figure out our 2 roots for this equation. I hope you like it. I'm not going to explain the rest now. We did talk about with the quadratic formula, the vertex. We've already discussed that for the x coordinate of the vertex. Assuming we eliminate the a, we get negative b over 2, just like with the quadratic formula, so it can still be used as finding the vertex. And we also talked about the discriminant, which in the quadratic formula was b squared minus 4ac. We're not going to get into it now, but I'll just tell you that the discriminant in the magic potion is what I'm going to use for the discriminant. There is a little flexibility. I don't have time to explain it now. It's not really important, but what I find to be a very easy way to do it, since right here we end up with a z squared. This z squared turned out to be 5/2. This z squared is our discriminant. And so if z squared is positive, we're going to get 2 solutions. If z squared is 0, we're going to get 1 solution. And if z squared is negative, that's where we get no real solutions. And you'll find out that that will be helpful in Pure Math 3 when we get to complex numbers. So I'm really excited about this new method, and I hope you like it. I hope that some of you will choose to use this and implement it in your math work. I expect to see it to come out in curriculum in the future, and it's nice to see new math on the high school level. So thank you again for joining me. I hope you enjoyed it, and I hope you can be successful in your quadratic solving quadratic equations. So see you next time.